1950s when most of the agriculture in this area started to conclude. We started to see more movement out of the city of Detroit to the suburbs, and Farmington and Livonia very quickly became urbanized areas. Lots of parking lots, lots of roadways, and lots of subdivisions. So here we can see a map of Terabithia Creek today. This is the section between 8 Mile and Farmington Road. You can follow the trees, right? That's the path of the creek. Essentially, this is the width of the theme of floodplain, which is an area you usually wouldn't want to build in anyway. These days it's regulated to build in it. But pretty much, we have used all of the land right up until that floodplain boundary in order to create houses. And in many cases, we have houses that are directly on the creek or have views of the creek. This here, some of the subdivisions off 9 Mile and Drake. You can see there we've actually mowed down most of what was in the floodplain, and so these backyards essentially directly abut Terabithia Creek. And in addition, what's changed is the way that the water gets into the creek. Instead of infiltrating into the ground or even coming through tile drainage, now we've taken most of our tile lines or other drainage structures and replaced them with municipal storm sewer systems, which again are great for moving water off of the land. Problem is that water makes its way to the creek very, very quickly. It flows off of an impervious parking lot, it goes into a catch basin, it goes into that storm drain. Sometimes only a few minutes after hitting the ground, it's already making its way to the creek. This has gone hand in hand with the loss of wetlands here in southeast Michigan. Wetlands play a huge role in the regulation of stormwater. They basically serve like big sponges on the landscape. They're temporary storage areas for that rainwater. They kind of act like how we use detention ponds today. They treat and clean water by uptaking pollutants through vegetation. And they also serve as excellent habitat for things like fish, amphibians, and birds. And so through urban development, by filling and losing these wetlands, we've lost all of these important wetland functions that we used to have on the landscape. And you can see from the wetland development map down there, Wayne County, on average, we've lost as much as 90% of our pre-settlement wetlands. Oakland County, we're doing a little bit better, but the parts of Oakland County we're talking about are definitely up closer to that 90% threshold here in Terabithia Creek. And so the combination of all of these factors has led to a huge impact on the hydrology of Terabithia Creek. And hydrology is just how we describe the movement of water off of the landscape, how water moves through different sources and sinks. And one of the key measures of hydrology of the system is what's called the hydrograph. So here's sort of an idealized hydrograph. This is just a measure of stream flow over time. So it's both the volume of water that's moving through a stream and it's the rate at which that water is moving. And so this shows how a hydrograph would respond to a storm event. So down here, this is before a storm event happens. We're at what's called base flow. This is just the water that is naturally in the creek, usually from groundwater. Storm event starts probably right around here. There will be some amount of response time. And then eventually over time through runoff and through groundwater, that storm water reaches the creek, levels and velocities in the creek go up. Eventually that storm event stops. And over time, the hydrograph starts to make its way back down towards base flow. So that's what it would look like in a natural watershed. But in an urban watershed, that effect is essentially enhanced, right? First of all, we start at a lower base flow because we're not letting water infiltrate into the ground. It's going into the storm drains. And then it's very quickly making its way off of those impervious surfaces through the storm drain and all entering the creek at once. And this creates an effect that we call flashiness, right? The water level is moving up very, very quickly and it's falling back down very rapidly, which does not mimic a natural condition in a creek. We can look at real data and see that this is in fact the trend that's going on in Terabithia Creek. Fortunately, the USGS, who does this monitoring work, took away their gauge in Terabithia Creek, but this is the Upper Rouge downstream of the confluence with the Bell Branch and Terabithia Creek. This is a rain event from about 2 weeks ago. We had some of those big storms that came through. You can see the flashy response of the watershed, and it doesn't take much to see which of these sort of modeled hydrographs we're closer to, right? When it rains, the water level in that creek shoots up very quickly and then drops back down very fast as well. And this has some wide-ranging consequences. So that's a part of preparing for this presentation. I went out, I walked the creek, I went from 9 Mile and Drake. I did a little section of the between 8 Mile and Farmington, then I walked the whole section from 7 Mile to west of Merriman Road, just to get an idea of what conditions in the creek were like and how this flashy hydrology is impacting the creek. So don't say I didn't put in the work before this presentation. And I saw some interesting things that would support many of the things I'm talking about, but there are also some encouraging things out there as well. But one of the big impacts of flashy hydrology is the erosion of the stream bank, or what we would call the degradation of the channel, the loss of sediment from the channel and the loss of stability in that channel. Here's a great example of that. This is on the west side of Merriman Road after the road stream crossing. You can see this outer bank here, what we would call the cut bank, which receives most of the energy of that creek, has severe erosion. We've got almost a bluff that's been forming here. That bank has most likely been moving back over time, potentially threatening buildings and property. In addition, we have what's called undercutting, where you can see the exposed roots of trees and vegetation, which normally help hold the bank together, are being scoured out by these high flashy flows, which is ultimately destabilizing the bank. We have another impact from flashy hydrology that is related to this scour and undercutting. That's what we call entrenchment. And that's where a stream channel essentially gets cut off from its floodplain. So in natural conditions, what would happen is you have the base flow in the river. That stormwater would come in, it would slowly make its way up, it would spill out into the floodplain, and then over time make its way back down. And that would help keep the channel stable. But in urban streams, especially in urban streams that have been channelized as a result of agriculture, this scouring effect, not only does it scour the bank, but it also scours the bed. And it moves the bed elevation of the stream channel down. So what happens is when all of that water comes through, instead of moving up and accessing its floodplain, it stays mostly contained within the stream channel, which might sound like a good thing, but it actually, by keeping that water in the stream channel, we're further contributing to that erosion effect and that scouring. We also have some localized, what we might call gully erosion. This is an effect of runoff overland, carving out stream banks. And I can actually pretty clearly see in some places in Terabithia Creek where this entrenchment effect is happening. So here's the outer bank. This is the cut bank where we would expect to see that erosion, but on the inner bank, we would expect to see what we call a point bar, which is a place of slower moving flows where the water is allowed to move up and access its floodplain. And you can actually see that pretty well here. See how the inner bank has some deposition and not this steep bluff here? So this is a place where when these flows come up, the water can more easily access its floodplain. But down here you can see the conditions on either side of the channel. They look pretty similar, and that's because the channel in that location is basically trapped. It doesn't have the room to access its floodplain and do what the river wants to do naturally. And throughout this walk, I saw a mix of these areas, so I wouldn't say the issue is too bad. And most likely, this section of the creek was never channelized by agriculture. That was probably more of the smaller tributaries that feed in. And so overall, it wasn't too bad, at least compared to some of the urban streams I have seen. Now, when you have degradation, you also have aggregation. That bank is eroding away, that sediment is being transported downstream. It's got to go somewhere. And I actually love this picture that I took here. Here you can see, this is the outer bank here. This is the bank that's starting to grade, or where some of that sediment is starting to settle out. And it's about 100 yards downstream from the picture of the erosion I showed in the last slide. And you can't tell from the photo, but the size of this point bar, you could literally take it like a puzzle piece, pick it up and stick it in that bank. And basically, where did that bank go when it all eroded away? Well, it settled out somewhere downstream. And this has negative effects too. It fills in some of the spaces at the bottom of the stream we call interstitial spaces. These are important habitats for fish and invertebrates. It's also where most of the oxygen exchange occurs in the stream that these organisms need to breathe. And so by filling in these spaces along the bottom of the stream with too much sediment, we're essentially choking out that stream. We're reducing dissolved oxygen and making it harder for organisms to survive. You can see here's another place where we have islands of sediment depositing in the middle of the channel. And this, during a big rain event, will all eventually flush out and eventually make its way downstream into an impoundment or another lake, and it will have negative impacts down there. In many cases, sediment also can carry with it other types of pollutants, like nutrients, which can be bad for water quality in the receiving waters of streams. So even though this process of degrading and aggrading is a part of any stream, when we have flashy hydrology, essentially the balance is off, right? We have extreme erosion in some places, we have extreme deposition in other places, and that ultimately negatively impacts the habitat that is available for organisms. And that's something that we were able to observe on our walks of Terabithia Creek as well. It's the loss of in-stream habitat. Usually we think of, okay, there's a river, it's habitat, that's where fish live, but if anyone here is a fisherman or is enthusiastic about water quality, you know there's actually a lot of diversity of habitats within a creek. And so a typical creek would be meandering, and you would see different, what we call morphologies, different structures within the creek that are places that different organisms can live. Places like riffles, which would be shallower water with high dissolved oxygen. Below them, deeper pools where fish can shelter and hunt. And then, as I mentioned, some slower flowing areas where we have point bars, or places where we have undercut banks where fish can go to hide with overhanging vegetation to provide shade, cooling, and shelter. But when we have flashy hydrology, we flush out a lot of that stream, we reduce the diversity of the morphology within the channel, and we end up with uniform habitat. And I saw that at several places throughout Terrabisi Creek. Again, this is up at 9 Mile and Drake. I don't know if anyone lives here, but we gotta tell them not to mow right up to the edge of this creek here. Complete loss of any form in the channel there. We've lost the overhanging vegetation that's providing habitat. And within the channel itself, it's just slow flow and deposition. There's none of this variety that the fish and invertebrates need. This is actually just downstream from there. This is on the underside of a poorly designed road stream crossing. And you can see the impact of that. What happened is between the flashy hydrology and the undersized culvert, we're shooting all of the energy straight down into this creek. And it's removing any of the diversity of habitat in that area. So again, it's just kind of a straight uniform channel, uniform depth, no structure, no good places for fish or bugs to hang out. I do want to take a little bit of it aside and talk about log jams, just because this was identified as an issue of importance to this group, and one that's caused a lot of controversy, potentially. I always say if you want to get a group of stream managers to argue with each other, just bring up the subject of log jams and coarse woody debris, and they'll fight about it all day. It's really something. But I think there's been kind of a negative connotation associated with log jams, and we definitely recognize that log jams do occur more often in these flashy systems, right? The banks are being eroded, the woody debris is falling in, and they are more common in these urban streams. And so the question that we as stream managers have to ask is, are these a symptom of the problem of urban hydrology, or are they themselves actually causing more problems within the creek? And the answer is a bit of both, but a lot of the research over the last couple decades has really showed us that there are a lot of benefits to maintaining woody debris in the stream. So what I want to do now is I just want to go over a couple of sort of the pervasive myths that I hear about log jams, and then we can talk about situations where it is or isn't appropriate to try and remove a log jam to protect the health of the creek. So probably one of the biggest ones I hear, and probably one of the most common calls I get, is that log jams are causing problems for water quality in the creek. I think a lot of this comes from what we often see behind log jams. This is somewhere in Rotary Park. We've got Gatorade bottles, we've got tennis balls, plastic water bottles. I've seen more unsavory things behind log jams. And then also it's very common to see something like this, some kind of foam accumulating behind the log jam, very brown, usually kind of brown in color, a little bit unsightly. And so I think a lot of people tend to associate those issues with the log jam. But remember, this is just occurring because things are accumulating, the flow is slowing down, it's attenuating, and things are accumulating behind that log jam. So that debris was put into the river, either thrown there by someone or carried by stormwater runoff. We're only seeing it there because it's getting stuck behind the log jam. If we remove the log jam, that would just go downstream. It would be somebody else's problem to deal with, which might be nice for the person who lives there, but it ultimately doesn't solve the problem. So if anything, log jams provide a nice opportunity for us as people who care about the creek to go out there and pull some of that trash out. Additionally, the foam that we see, that is a natural occurrence. It results from the decomposition of organic matter, leaves, and wood. It's composed of tannic acid. You can see it in natural streams as well as urban streams that are impacted. It doesn't have any harmful impact on water quality. So